Welcome to the next video in a course in discrete mathematics. This is lesson 4, discussing conditionals. In this video, we'll discuss the introduction of the concept of the conditional, definitions of antecedent, consequent, converse, inverse, contrapositive, and actually I think I need to add in here the biconditional. Examples and exercises at the end. I want to start by just giving some extra reading assignments. So read the section of the textbook that discusses conditional propositions, as well as you might as well go ahead and read the section on truth tables while you're at it. They kind of go together nicely, and it might help you to understand some of what we're doing here. In the 9th edition of the Rosen textbook, this corresponds to subsections 1.1.3 and 1.1.4. Now, to begin, this is yet another binary operation to construct propositions. Now, we saw the conjunction, the inclusive disjunction, and the exclusive disjunction. They were all binary operations that construct a new proposition from two existing propositions. This is the same, but debatably, perhaps, this is the most important among them. It, really sort of if-then, right? That's the conditional. It kind of models the behavior of the if-then clause, like in, if this triangle is acute, then it is not a right triangle, for instance. That's a conditional proposition. And the reason why I say that this is the most important, there's a couple reasons. One is that if you look at just about any significant mathematical theorem, it is almost always stated in conditional form. So it's just the form that you most need to encounter and get good with when getting good at mathematics. Also, it is closely related to the concept of logical inference, which is one of the most important concepts in all of logic, is how to take a given body of knowledge and extract from it the things that all of the ideas that can be obtained from that body of knowledge. So in any case, the conditional, very important. You want to make sure you understand this one. When we talk about a conditional proposition, it is put together by, starting with the word if often, doesn't have to. Plenty of conditional propositions, especially in English. I don't know necessarily how it is in other languages, but sometimes we obscure the keywords that signal an if-then proposition. But if is a good indicator of the first proposition, and it really is important to distinguish the first proposition, the one that comes after the if, that we call the antecedent. And if we're being very helpful for the listener, then we'll use the word then to indicate the next proposition, which is called the consequent. So, if this, then that is the structure of a conditional sentence. The if part is the antecedent, the then part is the consequent. Keep in mind that what a conditional sentence expresses is not the same as a conjunction, which is a mistake that a lot of people make. In particular, a conditional sentence does not claim the truth of the antecedent. It assumes the truth of the antecedent, and then conditional on the truth of the antecedent, it goes on to make a claim, which is the consequent. So it only claims the consequent under the assumption that the antecedent is true. So to illustrate some of what I'm saying here, consider the proposition, if the triangle is acute, then it is not a right triangle. That is a true proposition. If you say that about a triangle that happens to not be acute, it's still a true sentence. That's kind of getting at the fact that, the conditional sentence does not claim that the triangle is acute. It just says if it is acute, then it is not a right triangle, right? So if you give me an acute triangle like that right there, then the claim applies to it, and we claim that it is not a right triangle, which is true. If you give me a not acute triangle, like for instance this one with a right angle right here, because that makes it not acute, we are not right. Basically, in effect, the claim no longer is about this kind of a triangle, and yet it is still a true sentence. So be careful about that. Let's consider another example. So if Jennifer went to the store, then she bought bananas. Here are our two constituent sentences, the antecedent and the consequent. Let's again look at a table where we run through all of the possibilities for the truth of the two constituent propositions. So it could be that both are true, that Jennifer did go to the store and she bought bananas. In that case, we are in the situation where the conditional is making a claim, and the claim that we make in that situation turned out to be true. So it must be a true proposition, right? This is a sort of scenario in which the conditional comes out true. Now, what if Jennifer did go to the store, but she did not buy bananas? Well, in this scenario, it's certainly a scenario that the conditional is making a claim in, right? It's in that context where the conditional is supposed to actually claim something, and what it claims is then wrong. So that is a scenario where the conditional comes out false. Now, in the remaining scenarios, these are basically, scenarios which the conditional does not make a claim about. And so we regard this as true because, when a conditional, says something, but this, does not, the conditional does not apply in that scenario, then it should, effectively still be allowed to be true, right? Again, think back to the example of the triangle situation, or where we knew that the conditional was true when the antecedent was false. So again, because these can be quite slippery things, and in my experience teaching this material, lots of students, myself included, I think when I initially studied this stuff, did not quite understand this. And so I want to just make another note that if the antecedent is false, the conditional is still true, right? So I'm kind of just repeating what I've already said. So so a lot of people make the mistake of thinking when the antecedent is false, the conditional should be false, but that is not true. Now let's move on to another very common mistake, although this one different from before. It is the mistake of thinking that the conditional sentence basically says the same thing no matter which is the antecedent and which is the consequent, right? If you swap things around, it would be the same claim. And you may, right, I know that I have in fact noticed people in political debates and other scenarios, demonstrating this misunderstanding all the time. And so if you become attenuated to this issue, you may start noticing people around you making exactly this confusion very often in natural everyday life. So again, for an example, if the triangle is acute, then it is not a right triangle. That is a true proposition. If you flip it around, if the triangle is not a right triangle, then it is acute. Well, that is clearly a false proposition because you could have an obtuse triangle, right? An obtuse triangle would be not a right triangle. It has an angle that is more than 90 degrees, so it is not a right triangle. None of the angles are 90 degrees. But it does not follow that it is then an acute triangle, right? So this one was a true sentence, right? Where all the angles are smaller than 90 degrees, then that one's not going to be a right triangle because then none of the angles can be 90 degrees. But if you flip it around, you now get a false sentence that shows you that it matters which one is the antecedent and which one is the consequent. Now, although the two propositions, if this then that, and what you get when you swap it around, they are different propositions, but they are related, and very often it will happen. And it doesn't have to. We've seen examples where they, in one direction it says one thing, in the other direction it says another thing, and but there are lots and lots of cases where both directions are true. And so for that reason, we want to study, what happens when you take a given conditional and flip its direction. So if you take, for example, the proposition, if x is even, then x is divisible by 4. It's a false proposition, but if you form the reverse, right, you flip it around, if x is divisible by 4, then x is even, that's a true proposition. Well, that is called the converse of the original conditional, right? So the converse is the conditional that you get when you swap things around. That's not the only manipulation that you can do for a conditional proposition. You can also take the inverse, and that is what you get when you negate each component proposition, right? You negate the antecedent and you negate the consequent. So, for instance, if x is even, then x is divisible by 4. Its inverse is if x is odd, because that is the negation of x is even, implicitly using the background knowledge that a number must be either even or odd. Of course, I'm imagining here natural numbers or integers. But in any case, so this x is odd is the negation of x is even, so we negated there. And then x is not divisible by 4, that is the negation of x is divisible by 4. So this is the inverse. And let's look at one more construction that you can do. So basically the idea is to do both of the constructions that we just talked about. And it doesn't matter which order you do it in because you get the same thing either way. So you do the converse and the inverse, right? So the converse, you swap them around, and then the inverse is you negate each of them. So if you take, again, this proposition, if x is even, then x is divisible by 4, this is called the contrapositive, where you do both. And so we put x is divisible by 4 over here because it's the converse, but we also negate it, so you get x is not divisible by 4. We put x is even over here, but then we negate it, and so we get that x is odd over here. This is the contrapositive. Now let's take a moment to consider yet another thing that people often get wrong with the if constructions, and this is more to do with how to read the phrase only if. So take, for instance, and this is a whole scenario. The scenario is going to matter for understanding how this works. So imagine a knight who's trying to rescue a princess. To do so, he must slay a dragon and then cross a moat guarded by an ogre. Now, in this scenario, you should agree that the knight will save the princess only if he slays the dragon, right? It's not the only thing he has to do, but he will save the princess only if he slays the dragon. That's a true sentence. Now, what does it mean? Does it mean that if he slays the dragon, right, since this is the part that is indicated by if, then is this the antecedent? Does it mean the same thing as if the knight slays the dragon, then he saves the princess? Well, it can't mean that, because that's a false proposition, because then there's the issue of the ogre, and the ogre might get him. So, so this is a false sentence. This is a true sentence. Clearly, they can't mean the same thing then. So what does it mean? Well, no, it must mean that if the knight saves the princess, it's the other way around. It's the converse of what we talked about before. It's right. So by saying the knight will save the princess only if he slays the dragon means that actually the earlier part is actually the antecedent. It's if the knight saves the princess, then he must have slayed the dragon. So This is often confusing, but effectively what it means is that the presence of the word only in a conditional sentence effectively reverses the direction of the conditional. Okay, let's look at some examples. There's nothing much that's new here, but we've already looked at some examples. But Andriy will go to the party only if Darnya does. So that's an only if proposition. What is it equivalent to if we didn't use the phrase only if? It's equivalent to if Andriy will go to the party, then Darnya goes to it. Right, so again, seeing that it reverses the direction that you would get if the word only did not occur. How about the proposition, if the shape is a rectangle, then it is a polygon? What is that if we tried to state it using the only if? It would be the shape is a rectangle only if it is a polygon. And now we have the last propositional operator binary propositional operator that we will introduce in logic, and that is the biconditional. So this is merely saying if and only if, right? So we are essentially saying the if part, which means, if one of its angles is a right angle, then this triangle is a right triangle. But it's also saying the only if part as well. So effectively, it is the, this sentence and also this sentence, which is just the other way around, right? So it's stating the conditional together with the converse of the conditional. That is what the biconditional expresses. Okay, let's look at a couple exercises. So for each of the conditional propositions below, find its converse, inverse, and contrapositive. Now, suppose that the sentence, if the light is green, then you can go, is a true sentence. So also, and I didn't write this out, so I'll just go ahead and write it out now. Also, suppose that the consequent is false. Which in this case means that you cannot go. What can you infer, right? If it is given that the conditional sentence is true, but the consequent is false, what can you infer? And finally, I'd like to close with an invitation to ask questions. If there was anything confusing in this video or in the associated readings, then please leave a comment with a question. Ask it as clearly as you can. And if I can address it in the comments, then I will. And if it's a more substantial thing that kind of needs its own video, then I may make one and insert it into the playlist.